This is the foldable for section 5.2. We're going to fold it inward. 5.2, and we're looking at medians. What a median is that it's a segment that goes from the vertex to the middle of its opposite side. That means that these two sides are equal. So that means that we're working with congruent sides or congruent segments. Okay, where all the mediums meet is called a centroid. So this is a centroid of the triangle. Let's take a look inside. We have that D is the centroid of the triangle ABC. So centroids again came from a vertex to the opposite side in the middle. That means that this is equal to this. This is not 90 degrees, so we actually don't know the angle measure. All we know is that this side is equal to this side. So we have BE is congruent to EA. So the segment BE is congruent to EA. So this one is equal to this one. We have AF is congruent to FC. And then CG is congruent to GB. The distance from the centroid to the vertex is 2/3 the entire distance. So I'm going to focus on the one I highlighted, and what it's saying is that this is 2/3 of the whole line. What I like to tell students is that this whole segment is cut into 3 equal parts. So let's put a measurement just on here so you can understand better. If I tell you that this is 6, or AD is 6, then we know it can be equal to two equal parts, 3 and 3. That makes this distance DG also 3. That's where they get the 2/3 from, because it's 2 parts of 3. Now we can find this distance, and the entire distance AG. So that means that AD is 2/3 of the entire distance AG, or the entire medium. ED would be then just 1/3 of the entire medium CE. BD would be the longer side, so this is the 2/3 of the length of the medium BF. DG is the smaller part, so this is 1/3 of the whole segment AG, or the whole medium AG. BC is the larger part, so this would be the 2/3 of the segment CE, the medium CE. And then DF is the smaller portion, so this is 1/3 of the whole medium BF. Let's draw the centroid. When all the mediums meet, it's called a centroid. And centroids are always in the interior of a triangle. So let's draw some mediums. What we want to do is find the middle and go to a vertex. So the only thing we know is that these two are equal. So try to find the medium, the middle, and go to a vertex. Trying to find the middle and go to a vertex. And this would be called the centroid. This is a centroid. Okay, so from here, we got one in the middle. Oh, and we gotta go to the opposite vertex. go to the middle, and go to the opposite vertex. And towards the middle, and go to the opposite vertex. And we got our centroid. So from the middle to the opposite, oh no, from the middle of the segment to the vertex. From the middle of the segment to the opposite vertex. From the middle of the side to the opposite vertex. This right here is called the centroid. Okay, let's take a look at the other measure of a triangle is the altitude. So the altitude is just like in a mountain, the height of the mountain. And what you do is go from the base to the very top at 90 degrees to measure its height, like its altitude. So this has to go straight up. That means that 90 degrees are perpendicular. It means that you are working with right angles. Okay, if we look over here, it says, oh, sorry. An orthocenter is where all the altitudes meet, and this is called an orthocenter. And I know I mentioned it several times, but where all the mediums meet is called a centroid. Okay, so for D is the orthocenter of the triangle ABC. Then we're looking at this angle right here, angle AED. AED is this angle right here. They have to be created at 90 degrees. That means that this is congruent to the angle BED. So once again, we're doing the same letters at the end, just starting from a different point. We're referring to this angle right here, BED. Okay. The next angle is angle CFD. That's this one right here. That's angle is congruent to the angle AFD. Last one is angle BGD, which is congruent to angle CGD. We'll look over here. The orthocenter can be on the interior, exterior, or on the side of the triangle, sort of like the circumcenter. So again, how we draw those is that we're at 90 degrees. So we line up the ruler and go to the vertex at 90 degrees right here. So I want to point out that this doesn't look like it's equal. We're not trying to go equal. We're just trying to find the height. Then we go from the base and go straight up. So for these, you're trying to line up your ruler to the base and go to the vertex. And so I'm going to say it again. We're trying to line up the ruler to one side of the triangle and then move your ruler so we can be right on the vertex. And these are altitudes, and when all the altitudes meet, it's called an orthocenter. Okay? When you have a triangle like this, remember, when you're trying to go to the triangle and line up the ruler on that side and then go to the vertex. And this will actually end up on the side of the triangle. Okay, so I'm going to show you again. You line up the ruler to the side that you're referring to, so I'm going to keep it here. And you move the ruler to the vertex. And this will end up being the side of that triangle. And I just extended a little bit out so you could see that it was there. And then from here, you line up the ruler and you move it so you can have that vertex and that the ruler is lined up like this. And this is on the triangle. So this ortho centers on the triangle. So for an acute triangle, it's on the inside. For a right triangle, it's on the side. So for a obtuse, let's see what happens. We're at a, you have your ruler line up to the side of the triangle, and then we're going to make the altitude, that means at 90 degrees. We line it up to the side of the triangle, and then we go to the opposite vertex. So I know that this is hard to tell what I'm doing. So I'm looking at this one. I'm gonna line up my ruler, look at this line right here, and then I'm gonna follow that line until I hit the opposite vertex, which is up here. So I'm kind of leaving the triangle because my line's not long enough. This line wasn't long enough, so let me create it longer. So then I'm going to line up my ruler to that one again, and then keep following it until I find that opposite vertex. And I do it again here, so I will assume that I don't have enough lines, so I'm going to extend the line of the triangle. And now I'm on this side, and so I want my ruler to line up with this one. And I'm moving it so I can find the vertex. And it looks like that ortho center is all the way up here for an obtuse angle.